Okay guys, welcome back. We have another PowerPoint here. This one here is on sketching nonlinear equations. Okay, so over the first term of Year 9, we had a really good, really detailed look at sketching linear equations. Okay, equations of a line. We looked at gradients, y-intercepts, slopes, all that sort of stuff. We got really detailed into it. Of course, as with maths, we like to move on to the next thing, and we are going to be looking at non-linear curves this time. Okay, so first things first, we need to make sure that we can remember some of the key concepts, and the coordinates are going to be some of our building blocks that we need for this stuff. Okay, so if you can't quite remember, our coordinates, okay, a little bit like Battleship, right? We have our x coordinate for our x-axis, okay, and our y coordinate for our y-axis. Of course, oh, that's not a line. Let's try. That's better. So x is an x, y goes here. So x goes across the page because x is across, and we have y to the sky. So another way you can think about it, when you read, you always go from left to right, across, before you go up or down. Okay. So that is our Cartesian plane, and our x-coordinate tells us where we sit along our horizontal or our x-axis, and then our y-axis, our y-coordinate, tells us all about where we are in our height or up and down. Okay, very important that we remember that. X comes before y in the alphabet, okay, so it makes sense that it comes before it in maths as well. Both of them are called the coordinate pair, so we will be spending a fair bit of time with these coordinates. So, how do we plot our graphs of linear equations, right? It makes sense if we're going to be doing non-linear equations at some stage, we should start with what we are comfortable with. Just make sure that we remember all that knowledge from term 1. So, the x-coordinate and the y-coordinate can be linked by a function, okay? And we saw that last term. So for example, okay, let's have a look at these coordinate pairs. So we have a couple of different coordinate pairs. We have 1, 2, 3, 4, 5, and 6 pairs of coordinates. And in each pair, the y-coordinate is 2 less than the x-coordinate, right? And you guys can really quickly check that. So if we have 1 take away 2, we get -1. 4 take away 2, we get 2, etc., etc. So all of these coordinate pairs follow that rule, that in each pair, the y-coordinate is 2 less than the x-coordinate. So that tells us something about how those coordinates are linked. Specifically, these coordinates are linked by the function y equals x take 2. So what we can do is we can plot this function. We can plot this linear function simply by plotting the point. Let's try that line again, a bit dodgy. By plotting the points that obey this function. Specifically, these 6 points. So let's have a look at these 6 points. So we have, where is that? That looks like this one here. Okay, -2. So in x we go -1, -2, and -4. So we need to go down 4 in y. In y, 1, 2, 3, 4, down. Down because it is negative. Okay. Next one here, well, it looks like this one because it is -x. So we go left 1 to here, and then we have to go down 3 in y. 1, 2, 3, etc., etc. Okay, hopefully this stuff is really familiar with you. I'm just going to run through these lines here. Okay, And so those are all coordinates on our line. And we can see that we've done a really good job of plotting them because that looks really, really straight to me. Okay, we're going to try and fill in a line between all of them, and our line passes through all of our points. So we know we've done a really good job. Our points all fall on the line, and we have absolutely sketched. So what I want you guys to do is I want you to have a go of this yourself. Okay, we start out here by filling in these table of values right here. Okay, so this is our line equation, our function for our line that we're going to use to plot over on our graph over here. Okay, so we've broken it down into steps. First things first, we need to find our values that we're going to plot. Second step, okay, well, once we have the values, our points, our coordinates, we can plot them on our grid. We can draw a line through those points. It should definitely be a straight line. Lastly, we like to label the line with the name of our equation. Okay, so then if we were to plot multiple equations, we don't lose track of which one's which. So if you guys would like to have a crack yourself, please pause the video and I'll see you in a minute. We're going to run through how we calculate these points and continue on our way. Okay, so welcome back. And first things first, we're going to look at filling in this table. So what we do is we have a look at our equation where we have 2 times x plus 5. And all that we do is we take turns substituting each of these points into our equation for x. So like substitutions in sport, okay, the x is going to come onto the bench, okay, it's going to go away, and negative 3 is going to come into the game. So it will actually look like, okay, I might do some working out over here, 2 times minus 3 plus 5. Okay, 2 times negative 3 is minus 6 plus 5, okay. Hopefully we agree that it's negative 1. So that is how you would get the answer negative 1 there. And what you can do is you can follow that rule, that process I should say, for every single y value. So this one here, okay, obviously, well, now we're going to substitute in minus 2 to our equation. So it would look something like, let's do some working out over here. I would have 2 times minus 2 plus 5. So following BOMDAS again, 2 times minus 2 is minus 4, plus 5 more, should get 1, and we get happiness. Following that process for all of our bullet points, and we can see a pattern develop like this. Okay. Now, one thing that you guys should hopefully notice is that every time we increase in x by 1, okay, so we're always increasing x by 1, we go minus 3, minus 2 to minus 1 to 0, 1, etc., etc. Our y is also increasing by a certain number. So let's have a look. Negative 2 to 1, 1 to 3, 3 to 5. So if I just write up here plus 1, plus 1, plus 1, plus 1, our y is increasing by plus 2. Okay, and that's no coincidence, right? Our rule up here with the 2 in front of the x tells us that. That is how much my y is going to increase for every single x. If you kind of forgotten a little bit how to pick up on those patterns, no problem. Doing your working out for all of them is not a big deal and something that I highly recommend until you get confident, because you don't want to get these coordinates wrong. But with that being said, once we do have all of our coordinates, we can go ahead and plot them on our grid. Okay, so just a matter of matching up the x's and the y. So let's have a look. Let's do some of these together. So if we do our first pair, okay, we're going to go to minus 3 and minus 1. Well, we need to go to minus 1, minus 2, minus 3 in x, okay? The negative is over on this side, positive over on this side. And similarly for y, well, it makes sense if we go up, we're positive, and down, we're negative. So we need to go down 1 to get that point there. Okay? You can follow that process all the way through until we get all of our points on our grid. We're going to draw a line through it and we're going to label it very nicely like that. So hopefully yours. Okay, so a non-linear polynomial equation is any equation, where the power, okay, is higher than 1. So what we're talking about is specifically the power of x. Let's have a look at some examples. We spoke about it briefly in that extension lesson previously, but if we have a look at some examples, let's have a look. This can be example 1. So we have y is equal to, so let's say x squared plus 4. So this is very different to the linear functions we've seen because it has this power over here, okay? X to the power of 2. So right off the bat, we have changed the power of x, and this is no longer a line. As we said in that extension power, this is what's called a quadratic function, and it has a very distinctive shape. We have a look at a different one. Y is equal to, let's go maybe 4x cubed plus 7x take 2. And again, even though we do have a linear equation with that 7x, so just x to the power of 1, okay, we do have this brand new term here, this 4x to the 3. And as I said when I was writing it, I said 4x cubed because this is a cubic function, okay? Polynomials are defined by their highest order, okay? So polynomials are defined by their highest order. Or power, okay, is another word. Okay, the highest power. So this is an order 3 or a cubic function. This is an order 2 or a quadratic function. We could have to the power of 4, power of 7, power of 120 million if you're that way inclined, okay? They are all not lines. They're all very interesting, and we're going to learn a little bit about them as we continue. So, sketching non-linear graphs. So when sketching non-linear graphs, it is often helpful to draw a table of values. So like we did in our example before with our linear equation, this is going to be our first step for these sketching of non-linear functions as well. Once we have our table of values, we then plot each coordinate pair on a Cartesian plane, and then we connect each coordinate pair with a smooth line. So nothing changes except maybe the function we use to draw a table of values. So I think if you were able to complete the linear equation earlier, there's no reason why you wouldn't be able to do this more complicated function here, okay? So what we're going to do is we're going to plot this graph down here. So we said first things first, we're going to draw up a table of values. So what we're going to do is we're going to substitute the x into our function here. So we had x squared take 3. So we could do some working out. Okay, so y is equal to, so as you said, we're substituting -3, okay, into the function. So we get -3 squared take 3. Now, you might notice that I threw some brackets in there. The brackets are going to be really helpful, especially if you're relying on your calculator. Because if you don't type the brackets into your calculator, you can get some funky answers, because it is -3 squared. -3 times -3 is +9, take away 3. Okay, +9 take 3 is 6. We can work that y value in. So, as we said, yes, this part might be a little bit more tricky, okay? There's a squared in there, and it'll take some time for us to get used to evaluating functions like that. But it's nothing new. It is still evaluating, it's still finding the y value, okay? And then filling in our table, plotting those values. So we'll move on, we'll try the next x value. So y equals -2 squared take 3. So -2 or -2 squared is +4, right? -2 times -2, take away 3. Okay, so I we end up with 1. Good. And we just continue this process all the way through. Okay. Equals -1 squared, take 3. -1 times -1 is +1. Take away 3, I get -2. And you might, oh, I don't need to write that in. There we go. Okay. And, so on, so on. So we can sit there and evaluate all the answers and get something like this. And you might notice that there's actually a really cool looking pattern there. So I'm really curious to see what happens when we start to plot these values here. I'm going to write down our coordinate pairs. Let's make some room. Okay. Writing down our coordinate pairs. So these are the coordinates that we are going to plot on our Cartesian grid. Here we go. So first one's first, we have -3x and 6. So if we go over to -3x, and then we have to go up to y6, so all the way up here, and that is where our plot is going to go. Then we obviously move across, so move across 1 in x to -2, and then we're only going up to y equals 1, so right here. Okay. Follow that process. Hopefully you guys can do that sketching, that plotting of points just as well. For this stuff, it doesn't matter. It doesn't matter if it's linear, it doesn't matter if it's cubic, quadratic, any sort of function. Now it's just a matter of putting points on our Cartesian grid. So I'm just going to remove those little points and we're going to plot them all in. Okay, join them up with a nice smooth line. We can see that that is definitely not a linear equation. It's no longer a straight line. It's in fact a more interesting curve. Okay, curve is called a parabola. It's formed by a quadratic function. It is really fascinating. It models plenty of real world scenarios and will pop up again and again as you continue to spend more time in your maths studies. Okay, so what we're going to do this time, guys, is we're going to step things up a little bit more and have a go at a cubic function. So we have our function here, y is equal to x cubed, okay? So that cube is the highest power in our term. It is what gives us the name, and it's how we know it is a cubic function and not a linear function, okay? Now, what we're going to do is we're going to break up our problem into bite-sized pieces. So we can see down here we have 3 columns. So we have an x cubed column, that's a row, an x cubed row, excuse me, a -7x row, and a +2 row. And that's just going to help us as we determine the value. Okay, if we break it up, then we're less likely to make some silly mistakes on our calculations on our calculator. So all we're going to do is we're going to determine x cubed for all of these x values, and then we'll move on to the second row and the third row. And finally, we're going to put all of our pieces together in each column to add up and determine what that y value is for that particular x value. So let's get started. So we want to have x cubed, so x value is -3 to the power of 3. And again, really pedantic about my brackets. I probably over bracket, and the reason for that is those pesky negatives can cause us dramas if we aren't paying attention. So putting in your calculator bracket, -3 bracket to the power of 3 will ensure that you always get the correct results. Okay, so maybe you don't need a bracket, maybe your number facts are really, really good, and you get that is -27, which is fantastic. As I said, we're going to move along the row here, and we're going to do -2 cubed. So -2 times -2 times -2. Well, I get -2 times -2 is +4, times another -2, we should get -8. Fantastic. So on and so on for the rest of the row. So again, we are going to be looking at -1 cubed. Okay, whacked it in my calculator. -1. I get 0 cubed. Whacked it in my calculator. 0 times 0 times 0. We should all get this one right. 1 cubed. 1 times 1 times 1. Great. 2 cubed. brackets there. 2 times 2 times 2 should be, oh, there we go, 8. And then 3 cubed, 3 times 3 is 9 times 3 more, 27. Fantastic. So we have that row complete. We're going to move on to the second row here, which is going to, again, I'll just show you some working. Minus 7 times minus 3. Okay, so as I said, this is kind of why I like putting in those brackets. So I'm just going to replace that x with whatever I'm substituting in. So negative 7 times negative 3, I should get positive 21. There we go. And being very careful with those negatives all the way through. So minus 7 times minus 2, okay? Negative times a negative gives me a positive. 2 times 7 is 14, etc., etc. Following that throughout the entire row, and I get all of these values. Last row is definitely the easiest because it is plus 2. There's no x's. All we have to do is write 2 into all the rows, right? Okay, there's no x's, there's no substitution, so it doesn't change depending on the x. It is just plus 2. Now, these are our building blocks. We need to put all of our building blocks back together by adding all the values in our column. So this is why we set it out this way, because we did all the hard work. Now it's simple. It's very easy to make a simple mistake if you're trying to evaluate this all in one step. So this can really simplify our problem. So now you can think about it as minus 27 plus 21 plus 2 more, and that gives us a total value of negative 4. And what we're going to do is we're just going to come along for all of these columns and do the exact same thing. Negative 8 plus 14 plus 2 gives us 8, etc., etc., for every single column here until we have our table of values. So our y values correspond to our y coordinate, our x values correspond to our x coordinate, and we have our pairs here, minus 3 and minus 4, minus 2 and 8. Our next step, as always, is to plot these. Okay, so let's have a look, plotting over on the right hand side, and it forms this really, I think it's cool. I think it's a really cool function, okay? That is what our cubic function looks like, okay? So that is characteristic of a cubic function, and we're going to spend a lot more time with a lot of these functions. At the moment, we don't really need to memorize those characteristics and what a cubic function looks like, because we are going to be sticking with those table of values and simply plotting them all together. Guys, that's about it for us. As usual, we have a worksheet for you to go and have a look at. Please practice that. If you have any questions, have a chat to your teachers, and we'll see you ready for the next PowerPoint.